today's lesson is about investigating condensation. To get started today, I want you guys to turn to page 11 in your workbooks. Know that for today's lesson, you're going to need 2 Ziploc bags. If you don't have Ziploc bags, that's okay. I'm going to do the experiment on video here, so you'll be able to watch it to take the notes that you need. But if you have 2 Ziploc bags, it'll be fun to follow along. So on page 11, the warm-up question presents you 2 different images, one with a puddle and one without. Both of these images are taken at the same location. So I would like you guys to think, what happened to the water in the puddle and why did that happen, and where did the water go? I'm going to give you guys a few minutes. Once you're done answering the question, press play on the video. Welcome back. So it's pretty clear that the water evaporated. Based off our last lesson, we know that the water evaporates and turns into a water vapor and proceeds to go higher up in the atmosphere. But where does it go? We know that it cannot be created or destroyed, so it has to have a new location or a new form. So today's lesson, we're going to investigate, after the water vapor, what happens to the water. So at this time, I want to introduce this key concept. When liquid water becomes warmer, it can evaporate and become water vapor in the air. All air contains water. So at any given time, there is water in the air. How much water is a variable, but at any given time, there is some type of water. So after the rain produced the puddle, the energy from the sun warmed the puddle, and the water evaporated and changed into water vapor. So at this time, we're going to start an investigation question. Remember that investigation questions are usually short-term questions that we ask when we're doing an experiment. And our question today is, what makes rain happen? In this unit, we are helping the townspeople understand what caused Galetown to have more severe rainstorms this summer than previous years. Before we do that, we have to first understand what makes rain happen. Understanding the water cycle is part of that. So here we have a picture of the water cycle, and circled in red is the condensation portion. And also, inside of the second picture, we have condensation forming a cloud in the weather pattern simulator. So one is a screenshot from the warm-up of yesterday, from the last lesson, and the one on the right is a screenshot from the simulator from the lesson on Friday. Remember that we are working to understand what makes rain happen. We saw in the previous lesson on Friday that evaporation is how liquid water gets into the air as gas. Condensation is when water vapor, the gas version in the air, turns back into the liquid water. What we're going to investigate in this lesson is, why does this condensation happen in the air to produce rain? So to investigate the question, we will examine what scientists call air partials. So an air partial is an amount of air that moves as a unit. You observe that what weather scientists call air partials in the weather pattern simulator last lesson, and they're usually represented by these boxes here. Rather than trying to study all the air on Earth, we study smaller sections of the air. We call these smaller sections the air partials. Studying smaller sections of the air helps scientists and us see how air moves through the Earth system. In real life, we don't divide air, and air is not separated into partials. But in the weather pattern simulator, an air partial is represented by the box, and we can see how things change based on the conditions outside of the partial and observe what happens. So it's really almost a tool. It's a term that scientists use to create a tool that helps us understand why and when things happen. So I'm going to pause this portion of the video and bring you to a live recording of me starting the project. Before I do that, I want to give you the instructions. You're going to need 2 bags and label 1 cooler and 1 warmer. And then I'm going to there's a set of instructions in your workbook, but you're welcome to follow along with me in the next portion of the video. All right, guys, so this is part of the hands-on lesson. So earlier in the video, I told you you needed to get 2 Ziploc bags and label them hot and cold, or warm and cold. So I have my lovely assistant here, Isabella. She hates that I made her do this video, but I'm forcing her to learn anyway. So what you need to do is open it up, but then close it almost so that you have just a little bit of space to blow air into it. So we're gonna have her blow air into both of these. And once you have them filled up like balloons, close it. Close it up tight. Tight, 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 tight. All right. And then next one. All right. You want to make sure that the same person fills up both of these.
No, it's not close all the way.
So this one that says cold, we're actually going to put it in the freezer. And the one that says warm, we're going to leave right outside here in the room, anywhere you want. So I need you to fill this one up a little more, though. Come on. And when you're done, you can put that in the freezer. And we're going to check back on these bags later on in the video. All right, guys. So we're in the simulator while we're waiting for our experiment to run out. I want to keep in mind that you guys should set the water partial vapor to medium high. And then also your temperature, you need to change to 37 degrees. Now, the reason why we're changing it to a warmer temperature is because the air inside of the Ziploc bags are coming from a human body, which is quite warm. And then the surrounding air, we're setting at 20 degrees, which is room temperature. Now, if you're not familiar with the Celsius conversion, you can always look up these numbers on online. They are very easy to find. So these 2 options right here are going to stay constant because the air inside of your body isn't changing and the temperature inside your body is not changing. What we are changing is the temperature outside of the bags. So this would represent the bag right here, and the outside temperature would represent either inside of the refrigerator / freezer or in on the room temperature. Once you set that up, I want you to press run. It's going to be fairly quick. And then on your pages in your workbook, pages 13 and 14, which I think are the directions, so it might even be on 14 is where the table is. It asks you to analyze the data here. So here we have 23 as the amount of energy removed or transferred out. Now, I want you to think back to the thermal unit and remember that thermal energy will go from the most thermal energy to the lower thermal energy, to the temperature. So inside the bag, it was warmer than the air outside, so it's being transferred out. And the amount of liquid is 2, as far as cloud, and the amount of rain is 0. So transferred out would be 23. Liquid water as a cloud would be 2, and liquid water as rain, 0. So the total between cloud and rain would be 2. Now we're going to go back into the building section and change just the surrounding temperature to mimic the the freezer situation, and set it to -4, which is slightly below freezing. And then they're going to press run, and you're going to notice that the yellow arrows point outwards, sending out the energy. And here we even see slight amount of rain. So the only thing that changed was the temperature on the outside. And let's click on Analyze. In the Analyze section, we have 6 for the cloud water, and then 9 let's keep it the 11 because we're going to want to use the same measurements. 11 kilograms of rain and 85 for the transfer of energy. Here, even though the bag was the same, the only switch was the temperature of water. And the temperature surrounding the bags. And we see that with more of a difference, when there was a greater difference between the bags and the outside temperature, it produced more rain. We're going to go back to our bags to see if we have similar results when we pull out and compare the differences between the two bags. All right, guys, so I'm back. I'm by myself. My assistant left. So I have the first bag, which was the warm air, and it kind of almost looks the same as when we started. Whereas if I take the cold air bag, you can see that there is some form of condensation. It's definitely cloudier than the other. So if I put them right next to each other, you can start to see that this one has more condensation, which actually is in line with our model on the simulator. On the simulator, we saw that when there was more energy transfer, there was more condensation and caused more liquid rain. So I want you guys to keep this in mind as far as claim 2 with the warmer weather causing more evaporation or hotter air going towards the colder air, because the air partials that were coming from the ground would have been warmer than before when there wasn't a heat surge. So I believe there are no questions for you to answer. But there is one more key concept, which we kind of already touched on already, and I'll post it at the end of this video after I combined everything. But when water vapor in the air partials cools, it can condense into liquid water, which can form a cloud and fall as rain. So this is going from warm, like your body air is warm, but the room temperature isn't that much different. Whereas when we did this one, your body is warm and it went to a freezer, which is much colder, and we can see there's a lot more condensation. 2 bags and with the simulator, and we kind of got the same results. I want to remind you of some of the vocabulary words from our thermal energy unit. Energy is the ability to make things change or move. Temperature, a measure of how hot or cold something is. And transfer, to move from one object to another or one place to another. When we're talking about this condensation issue, we're talking about the energy movement. When the difference between the temperatures were significant, we saw a lot more energy moving. So in this image, I screenshotted it from the simulator. You see that we have energy transferring out. Energy transferring out is represented by these yellow lines, which makes sense because if the water has heat from the sun energy, is raised as a gas, it is coming in as a warm or high temperature with a lot of thermal energy. Not a lot of thermal energy, but the average thermal energy is high, meaning the temperature is high. If the outside is much colder, there's going to be a lot more energy being released. And we saw that when there was a lot more energy being released, there was a lot more rain. When water vapor in an air partial cools, it can condense into liquid water, which can form a cloud and fall as rain. So I want you to think about claim 1 and 2 in this unit. Claim 1 talks about the amount of water on the ground. The lake increased the amount of water. And then claim 2 talks about the temperature change. this experiment kind of shows evidence for claim 2, because it shows that if the water vapor was hotter, or if there was more water vapor and then more thermal energy, when it came up as a cloud, it will have more energy to transfer out. So I know that it's been a while since we did thermal energy, but I want you to keep those concepts in mind about how energy goes from the hotter to the colder, and what happens when a gas gets colder. It becomes liquid. So if there's more energy being transferred and more energy becoming liquid, more of the water vapor becoming liquid, we have a larger amount of rain. If you have any questions about this, please message me on Jupiter and I will give you a more deeper explanation of this. But at this point, you should understand, based on the thermal energy rules, that if there's more hot water or water vapor going up to the sky, we have more warm air mass. With more warm air mass or air partials, it's going to expand the energy into the colder air that's in the atmosphere. If there's more hot water and more transfer of energy at a quicker rate, we're going to have more of that gas turning into liquid faster, and we are going to have more of it. And that's going to cause a more rain. So this information kind of supports claim 2. We're going to continue investigating because right now we have evidence for claim 1 and for claim 2, and we're going to work and see if we can rule out or we can include claim 3. You have some homework tonight. One is page 16, and the other is a reading which is on Jupiter. Tomorrow's lesson will not be recorded, as it is just simply a reading and answering questions on Jupiter. So you could do today's homework and tomorrow's lesson all at the same time, because it's just 2 readings and a 1 page on the back of on the end of this lesson. See you guys soon.